OSIRIS-REx is a NASA mission that visited asteroid Bennu, collected a piece of the fine-grained material from the surface of the asteroid, brought it back to Earth, and we now have a piece of it to analyse here at the Natural History Museum in our labs.
So Bennu is just over 4.5 billion years old, so it really takes us all the way back to time zero in our solar system. Bennu probably formed in the outer part of the solar system, but these days it's what we call a near-Earth asteroid. So it's actually much closer to Earth. And so the idea was to go, sample this asteroid, bring those samples back here to Earth so that we can use them to understand how Bennu formed. And Bennu is really amazing because as an asteroid, it's kind of like a leftover building block of our solar system. So when we think about how you make the planet Earth, all the ingredients are there locked up within Bennu. And so we want to kind of disentangle the story of Bennu and learn about the origin of the solar system and then the history of the Earth. This is a pristine sample. So we have a wonderful meteorite collection here at the Natural History Museum. Meteorites are brilliant. Most of those come from asteroids, but they all come through our atmosphere. They all land on the Earth's surface. They get collected. And so they're all contaminated to some extent. For Bennu, we have samples that we know exactly which asteroid and whereabouts on the asteroid they came from. So we have that kind of geological context. And then the samples have come back to us and they're in a completely pristine state. So they haven't seen any of the terrestrial environment. So NASA have got hold of these samples from Bennu and they're now distributing them to a team of over 200 researchers all across the world. We're really lucky. We're one of the first people to get our hands on the Bennu samples. And so here at the museum, we have a team of researchers that are going to start studying these samples, understanding what the mineralogy of them are, what's their composition. So I'm pretty sure when we start kind of unpicking these samples, we're going to see all sorts of interesting stuff that we maybe haven't seen in our meteorite records before. And it's going to tell us some really important things about what was going on in our solar system. And hopefully it will give us some clues about how the Earth ended up with water, why we have oceans, and ultimately why we have life here on Earth.
The sample, we believe, comes from the sort of asteroid that we think might be responsible for bringing water to Earth. So when Earth formed, it was quite a dry environment. It's obviously not dry now, there's water all over our surfaces, and we're also made of water. So we think that water was delivered from an extraterrestrial source at some point during Earth's later evolution. And we think that Bennu, this asteroid that OSIRIS-REx visited, could be representative of the type of asteroid that delivered water to Earth. So one of the big questions we're hoping to answer is that true? So we're going to be looking at the sort of water that these samples were exposed to and then comparing that to the water that we have on Earth. And then also we're going to be looking at the organic content. So when I say organics, I don't mean life, but I mean carbon-bearing molecules. So we're obviously made up of organic molecules built into life. And we find in some of these samples that are similar to Bennu, we find organic material. So we're going to be looking at the organic complement of this sample, trying to see if maybe these could have acted like a stock cube for life and were delivered to Earth. We've got a small vial of powder and a very small grains. And what we're going to be doing is we're going to be looking at those on the very micro scale. So we're going to be putting them in very, very large microscopes. Microscopes normally use light to look at them, but we're going to be using electrons to kind of probe the very micron scale and get an idea of the mineralogy of the sample. We're also going to be taking some of the sample and grinding it up. And we're going to be firing X-rays at them, and we're going to be looking at the way that X-ray bends as it interacts with the surface, and that also gives us an idea of the mineralogy that's in the sample.
I see this as being kind of the next era of natural history collections. We'll be collecting stuff from space as well as material on our own planet. So I think it's really important that we're involved from the beginning in this kind of work, and it's great to have international partners because this kind of exploration can only be done as part of big collaborations rather than kind of individual projects.